And how are you feeling in this part? Very good, Varsha. So students, let us begin the chapter. Today, in preparation of hydrocarbons, the second method, we have discussed first method, preparation of hydrocarbons from alcohols. Now the second method is from hydrocarbons. Hydrocarbons, two types, alkanes and alkenes. From these two compounds, we can prepare haloalkanes. Then the first part here, from alkanes. Alkanes, saturated hydrocarbon. That's why Lakshita, good.
Good morning, sir.
Good morning, beta. So be ready for this. Alkanes are saturated hydrocarbons. That's why when we convert it into haloalkane, this is the substitution reaction. Hydrogen gets substituted by halogen. Like an example, CH3, CH2, CH3, propane is allowed to combine with the reactions, some reactions I have taken, is allowed to combine with chlorine, Cl2, in presence of ultraviolet radiation, sunlight, UV. This is free radical substitution. This in presence of sunlight, chlorine is converted into chlorine free radical. And this free radical is going to substitute hydrogen from the compound. So it becomes, the product is like this, CH3, Cl, CH3 plus one more product, CH3, CH2, CH2, Cl. See that? Along with the hydrogen comes out in the form of HCl. Reaction is not balanced. Then this is 2 degree and this is 1 degree. Two possibilities are there. So this percentage is almost 55%, and here the percentage of this product is 45%. Okay? Why this difference of percentage? Even when we take chlorine, there is much difference of the percentage of these two products. The reason behind this is free radical. This is called free radical reaction. Free radical. It follows free radical mechanism. So here we get, before joining this Cl, it is going to convert into 2 degree free radical. And this is going to convert into 1 degree free radical. 2 degree free radical is more stable, that is the intermediate, as compared to 1 degree. Therefore, here we get 2 degree chloro compound as a major product. Are you following the point? We are going to get the mixture. Out of these mixture, one product may be major product depending on the stability of intermediate. Here 2 degree free radical is more stable. Here the delocalization of unpaired electron, its chances is maximum. That's why it is more stable as compared to this 1 degree. Therefore, we get this 2 degree chloro compound as a major product. Okay? Have you followed this point? So this is the one method of preparation. Another is, if you take ease of removal of hydrogen, then 3 degree hydrocarbon, where hydrogen is attached with 3 degree carbon, can be easily removed by, as compared to 2 degree, as compared to 1 degree. What is the sequence? Here there is 2 types of carbon. One is 2 degree, another is 1 degree. If one more is 3 degree carbon is also there, having one hydrogen, then hydrogen is coming out from 3 degree carbon preferentially as compared to 2 degree and 1 degree. So in this case, product will be 3 degree chloro compound. In this case, it will be 2 degree chloro compound and finally 1 degree compound. This is the chemistry behind this reaction. Okay. The another method is, if we take a particular compound like CH4, here I am taking a particular reaction, CH4 methane combines with chlorine in presence of sunlight. We get a mixture of various products. Mixture like one hydrogen removed, it becomes CH3Cl, hydrogen comes out in the form of HCl. If again combined with chlorine and sunlight, similar condition, then second hydrogen comes out in the form of HCl. We get another product, CH2Cl2. This is going to combine with chlorine in presence of sunlight minus HCl, it gives CHCl3, and finally it is going to convert into CCl4 plus HCl. Okay, these are the possibilities. Finally, we are going to get the mixture of chloromethane, dichloromethane, trichloromethane, and tetrachloromethane. That's why this method is not useful for laboratory preparation. We are going to get the mixture of various compounds, and that mixture has no purpose, no meaning for the laboratory use. If we are using these compounds as a solvent in industry, then this can be preferred there. Okay, that's a laboratory point of view. This reaction, this method is not so useful. If you go for different reactivity of compounds, like see that change condition, CH2 double bond CH bond CH3. Here is allyl compound, like this type of compound, allyl. Here hydrogen attached with sp3 hybridized carbon. Here it is sp2 hybridized carbon. Is going to combine with chlorine at very high temperature. Temperature is 773 to 873 Kelvin. 873 Kelvin. This is the condition. And at this condition, both the reactants will be in vapor state. This is called vapor phase reaction. Vapor phase reaction. This type of problem we have to also face in the exams. That's why we should take care. In this condition, this 1 degree hydrogen attached to 1 degree, that hydrogen is coming out. Instead of addition reaction, we are going to form the product. We are going to get the product in the form of substitution product. Hydrogen gets substituted by chlorine, and the product is, here the product is CH2 double bond CH, CH2Cl. This type of product is obtained, substitution product is obtained. This is the condition. See the condition. In this condition, instead of breaking the pi bond, double bond, here is breaking of sigma bond takes place, and that is coming out from this carbon where sp3 hybridization, this bond length is larger as compared to this carbon hydrogen and this carbon hydrogen. That's why product is like this. Okay. One more reaction. Here is toluene, also hydrocarbon. This is the hydrocarbon. Here is hydrocarbon. We are talking about hydrocarbon, and there are hydrogen involved, which is attached with the sp3 hybridized carbon. Here also this hydrogen involved. Here at this carbon is sp3 hybridized, and it is going to combine with chlorine in presence of, the condition is sunlight and reflux condition. The condition is reflux. What is the meaning of reflux condition? This mixture is heated for longer time in a closed container, which is connected with a long glass tube. A round bottom flask connected with a glass tube near about 1 meter long glass tube, and it is heated for longer time, more than half an hour. then this condition is called reflux. Yes, students, there is some difficulty, some problem. Now it is solved, and you will be able to find this. Lakshita, can you hear me? Can you see me? Lakshita?
Yes, sir. Yes, sir.
Yes? Good, good, good. So, see that this is the different condition. When under these conditions, these compounds are going to combine, we are going to get such type of products. Okay? That's why the order of reactivity here is different. This benzyl, allyl, alkyl, vinyl, these are the groups from where hydrogen can be removed, and the order is like this. Order from where the hydrogen is being replaced by halogen, that order is like this compound here is the order is benzyl. From benzylic carbon, hydrogen can be easily removed, and its ease of replacement is similar to allyl. This is greater than alkyl. This is greater than vinyl and greater than aryl. This is the ease of replacement of hydrogen from these carbon. If it is benzyl, hydrogen come out from CH3 easily, and if it is allyl, it is coming out, it is almost equal to benzyl, then alkyl and vinyl. This is the order of reactivity, from where the hydrogen is replaced by halogen, like especially chlorine and bromine, easily. So here we have discussed that this method has no much use for laboratory point of view, but if there is a chance of a formation of only one product like this compound, CH3, C, CH3, CH3. Here is also CH3 is going to combine with chlorine in presence of sunlight. There is formation of only one product, and that product is CH3, here CH3, here CH3, here CH2Cl. If chlorine is in limited quantity, we are going to this type of product as a major product plus HCl. For such type of product, we can follow this reaction. Okay? This is the one method, preparation from alkanes. Now the second method. Second method is from alkenes. From alkenes. Alkenes, there is double bond, that is pi bond going to break, and we are going to get addition product, alkene like this. Here is double bond combined with hydrogen halide, HCl, HBr, HI to form this type of product. See, pi bond is broken, and here is hydrogen joined to one carbon and halogen joined to another carbon. This is addition reaction, okay? And this addition reaction is taking place in two ways, and that rule is known as Markovnikov rule and anti-Markovnikov rule that you have studied in the 11th class. Here is the one part is according to Markovnikov's rule. Markovnikov's rule. And another part is anti-Markovnikov's rule. These rules you are knowing, that's why I have written these rules first. There is a difference in these two. That's why while writing the reaction, you will not be having any confusion. What type of product should be formed in this and this. This Markovnikov's rule is going on according to electrophilic substitution, electrophilic addition. Electrophilic addition. And according to anti-Markovnikov's rule, this is happening. Here it is called free radical addition. Free radical addition. So if the condition is according to Markovnikov's rule, take care, it is electrophilic addition, means first positive, that is H positive will join, followed by Cl negative or halide ion. If anti-Markovnikov's condition is given, that is peroxide is there, then it follows free radical addition, and here the addition is just opposite to the first case. That is the difference. Markovnikov's follow electrophilic addition and anti-Markovnikov's follow free radical addition. What is the meaning? Let us take example. Suppose CH3, CH double bond CH2 combines with HCl in presence, there is no presence, simply. HCl, HBr, HI, anyone we can take. This bond is broken heterolytically, and this forms H positive. Here H positive is released, and this H positive is attached to this. Okay? So, here it is.
Sir?
Yes?
Sir, bottom part of board is not visible.
This part is not visible. Up to this reaction, can you see? No.
No, sir.
It is not. Okay, okay. I can see the computer also. Yes. This reaction is not new for you. What I want to see here, if Markovnikov's condition is given, what should be the product? If anti-Markovnikov condition is given, what should be the product, and why is it so? The reason is also clarified here. That's why it will be easy for you. Here is CH3, CH double bond CH2 combines with HCl, maybe HBr, maybe HI, anyone. It is going to form, here this HCl, this is going to break heterolytically. H positive is formed, Cl minus is formed. First H positive is going to attack on this reactant. So this is the reaction here. Here is the H positive, Cl negative. It forms an intermediate. This intermediate is carbocation. This carbocation, and then after that, the Cl minus is going to join here. So the product is like this: CH3 bond C. Here is CH3. Here is H, and Cl joined to this carbon. This is according to Markovnikov's rule. How is it happening? Along with this, it forms HCl is joining that. See that this can be explained with the help of this mechanism. It is an alkene, maybe symmetrical, maybe unsymmetrical, combines with HCl. This is going to break heterolytically, and this H joined to carbon, this compound, and it forms this type of product here. Here is a H positive. Here is H positive. Anywhere we can join, and positive charge come over here. This positive charge, this carbon may be 1 degree, maybe 2 degree, maybe 3 degree. Here this carbon is 2 degree. That's why positive charge arise at 2 degree carbon. If it is 1 degree, like this 2 carbon atoms, it may arise anywhere. And if it is 3 degree, it may rise at 3 degree. The point here, 3 degree carbocation is more stable as compared to 2 degree and 1 degree. Here, two possibilities are there. H positive, if joined at this carbon, positive charge will appear at 2 degree. And if H positive joined to this carbon, positive charge appears at 1 degree carbon. 2 degree carbocation is more stable than 1 degree. That's why here the 2 degree product is as a major product. That is the point here. The second step here, it combines with Cl minus to form this type of product. Here Cl and here is hydrogen. This is the final product. So the point here, if this carbon is 2 degree product will be major. If it is 3 degree product will be more stable as compared to that, and finally 1 degree. The breaking of bond and joining of hydrogen is take place according to that 3 degree greater than 2 degree greater than 1 degree. The final product is like this. Here two possibilities: 2 degree carbocation charge here, 1 degree carbocation charge here. If it is, then it will prefer formation of 2 degree product. That is according to Markovnikov's rule. Okay. This carbon is unsymmetrical. This double bond is unsymmetrical. Carbon atoms are different, having different number of hydrogen. Then product, two possible product. Here one Cl joined to the 2 degree. It may be joined to the 1 degree. 2 degree product is the major product, and we write the major product. Okay, this is according to Markovnikov's rule. If it is anti-Markovnikov, I'm talking about the second type, addition of halogen acid according to anti-Markovnikov, then what is going to happen? Take care, for anti-Markovnikov, we take only HBr. For Markovnikov, HBr, HCl, HI, any one can be taken. For anti-Markovnikov, we take only HBr and presence is organic peroxide. Organic peroxide. That is benzoyl peroxide is the organic peroxide. This negative part, definition of the Markovnikov, anti-Markovnikov, negative bromide joined to that carbon which has double bonded carbon which has more number of hydrogen. Therefore, this Br will join to this CH2 and H joined to the middle one. The product is just opposite to the Markovnikov's rule. Here the product is CH3, CH2, CH2, Br. This is the major product. Another is also possible, that is in a small quantity. That's why no need to mention that. This is called anti-Markovnikov's rule, also called Kharas effect. This rule was given by the scientist. That's why it is named as Kharas effect. Anti-Markovnikov's rule, peroxide effect. These are the three names. Okay. Actually, in this, what is the mechanism? Why is it so? Here, this follow the free radical mechanism. That is the different than the first case. Here, this is the peroxide C6H5 COO C6H5. This is the benzoyl peroxide. Okay. Homolytic bond fission takes place. Shared pair of electrons equally distributed. That's why half arrow. And this half arrow going to form two molecule, two free radical C6H5 C double bond O. Here the free radical, low unpaired electron present over the oxygen. This is going to break further into C6H5 free radical plus CO2. Balancing is not necessary. Okay. So this is the free radical, benzyl free radical, phenyl free radical. This phenyl free radical C6H5 combines with HBr to form C6H6 benzene plus Br free radical. Okay. This Br free radical along with HBr is joining to this compound. First Br free radical joined to this, and it joined to this carbon, making unpaired electron over the second. That is more stable. 2 degree free radical is more stable than 1 degree. That's why in this condition, what is happening? CH3, again, this problem may come to you. It is not going to be visible. So what is happening here? CH3, CH, double bond CH2 combines with Br free radical. This is the Br free radical generated in this previous example, previous reaction is going to form CH3, CH, here is CH2Br, and free electrons appear at 2 degree carbon, which is more stable as compared to 1 degree. That is the turning point of the reaction. This is going to combine with HBr. HBr, it combines with HBr in the second step and form CH3, CH2, CH2, Br, and hydrogen free radical. That is the reaction. That's why, according to anti-Markovnikov, halide ion, that is bromide ion, joined to that carbon, which has double bonded carbon, which has more number of hydrogen. Is the chemistry of these two Markovnikovs, anti-Markovnikovs clear to you? Okay, students. So let us proceed for the next process. Any doubt in this reaction?
No doubt, sir.
Okay, beta. Okay, take. So these are the two methods. Third method. First method from alcohol, second method from hydrocarbons. Now the third method. Third method from halogen by halogen exchange. By halogen exchange. Exchange of halogen. And this reaction is the name reaction known as Finkelstein reaction. Finkelstein reaction. In organic chemistry, they will ask one question. Write about the following reactions. That is the name reaction. It may be of 2 marks or 3 marks. So in organic reactions, name reaction also a part of the question. So this is the first name reaction in front of you. Try to remember these names reaction. This is the one of the important name reaction in this lesson. Finkelstein reaction. Reaction is quite simple. Name you have to remember what we call this particular reaction. So this is Finkelstein reaction. This is going to combine a haloalkane with NaI. Here the exchange takes place. And we are going to get here, see that we are going to convert one haloalkane into iodoalkane. This X may be, here X may be Cl, this may be Br also. Means chloroalkane, bromoalkanes, they can be converted into iodoalkane. That is the reaction. And the condition is acetone reflux condition. Reflux again, reflux means heating of the organic compound mixture for a longer time in such condition that there is no loss of the substance. If any vapor is coming out, that vapor get condensed and returns back. That is called reflux condition. Heating without loss of any compound for a longer time. And the reaction is simple. This halogen replaced by iodine, we are going to get Ri plus NaX. Iodoalkane is obtained. Chloroalkane, bromoalkane can be converted into iodoalkane by this method. Acetone is the solvent for sodium iodide or potassium iodide. It is the solvent for that. This NaI dissolved in acetone and mixed with haloalkane and heated for a longer time. That is the condition. Okay. This another reaction, CH3, CH2, here Cl plus AgF, silver fluoride, AgF. This is going to form, in presence of CCl4, going to form CH3, CH2, F plus AgCl. This is another name reaction, and this is called Swartz reaction. This is called Swartz reaction. Means in this preparation, we are having two different name reaction. One is Finkelstein reaction and another is Swartz reaction. Okay, sometimes they are asking the note about this directly. Write notes on Finkelstein reaction. In this reaction, we have to write 2 lines about the reaction and then chemical equation. One more reaction is there, that is also Swartz reaction, CH3CH2Cl plus Hg2F2, mercurous fluoride. Here we are going to get again the fluoro compound CH3CH2F plus Hg2Cl2. This is also the Swartz reaction. Okay, 2 reactions in this preparation, Finkelstein and Swartz reaction. Whatever names reactions are coming, we have to tick them so that we can write later on clearly. And fourth method is from silver salt of carboxylic acid. Silver salt of carboxylic acid, silver carboxylate. And silver carboxylate is here. It is again the name reaction. This is called Hunsdiker-Borodin reaction. Hunsdiker-Borodin reaction. This is another name reaction, means a third name reaction. Hunsdiker-Borodin reaction, also important reaction examination point of view. Reaction is quite simple. We are going to have silver salt of carboxylic acid, CH3COOAg. This is the acetate ion, silver ion, silver acetate, silver salt of acetic acid is going to combine with Br2 in presence of CCl4. CCl4 is the solvent here again. Reaction is quite simple. This compound is going to break three parts. Silver combined with the bromine, another product is CO2, and third product is CH3Br. We are going to get CH3Br as the main product plus CO2 plus carbon dioxide plus AgBr. Means by this method we can prepare bromoalkane and chloroalkane. Instead of Br, chlorine can also be taken. So here it can be written as CH3COOAg plus chlorine in presence of CCl4 we are getting CH3Cl plus CO2 plus AgBr. Okay. So these are the methods of preparation of haloalkanes. Okay, students, any doubt here? If you are feeling anywhere some doubts, you can ask, you can clarify that. Okay, these are the four methods. While writing preparation, I am taking the another compound, haloarenes preparation of haloarenes. Haloarenes preparation. Simple. Two methods are there. Try to understand these two methods. Reaction is quite easy. You can easily understand this. The reactant will be benzene or its derivative, toluene, like that. Benzene, toluene is going to combine with, the first method is from arenes. From arenes. Benzene combines with chlorine in presence of anhydrous AlCl3, FeCl3. It may be AlCl3 also. See the reaction. This chlorine combined with benzene in this condition. In this condition, this is FeCl3, AlCl3. These are known as halogen carrier. They combine with Cl2 first and form FeCl4 negative ion and Cl positive ion. And that Cl positive is going to join to the ring. So this is the substitution reaction, electrophilic substitution. The Cl positive joined to the carbon which has more electron density. This reaction is electrophilic substitution. Here the product is all carbon atoms are identical. In benzene, Cl can join to any one carbon. Therefore, the product here Cl plus HCl. Chlorobenzene is the product. Okay. What is happening here? What is the chemistry behind this? The chemistry is like this. Chlorine combines with FeCl3 iron. It has vacant orbitals in Fe3 positive form. Vacant orbitals are present. D orbitals are there. And these D orbitals allow the Cl minus to join by means of coordinate covalent bond. It forms FeCl4 minus plus Cl positive. Chloronium ion is formed. Cl positive ion is the chloronium ion. Chlorination, bromination, both may take place by this reaction. Then this Cl positive joined to the benzene ring. Benzene, hydrogen everywhere, at each carbon hydrogen is there. All carbon atoms are identical in hybridization, and number of hydrogen combines with Cl positive to form chlorobenzene Cl plus H positive. A resonance structure is formed. For Cl positive join, form resonating structure, And this resonance combined with FeCl4 minus, we can write here FeCl4 minus to form FeCl3 plus HCl. That is the final product, FeCl3. Are you able to understand the role of FeCl3? It helps in generation of electrophile like Cl positive, chloronium ion. That's why this is called a halogen carrier. It carries one of the halogen from here, chlorine or bromine from here, in this form, releasing positive ion. That's why it is called halogen carrier. In the same way, AlCl3, it can extend its covalency because of the presence of vacant d orbitals, and it forms such compounds. Okay? Is it clear the role of ferric chloride? Another example, when toluene combines with chlorine, this chlorine can be replaced by bromine also. It combines with chlorine in presence of anhydrous FeCl3 or AlCl3. See that this CH3 has an electron donating effect plus I effect, inductive effect, and increases electron density at second carbon or fourth carbon or sixth carbon. That is the ortho-para-directive influence. Do you remember that point? We have discussed in 11th class. This type of CH3 or such groups which can donate electron pair to the ring, they exhibit ortho-para-directing influence. Therefore, we are going to get two products here. Here is a CH3 and Cl joined to this carbon, or another here CH3 and Cl joined to this carbon along with HCl. Due to the ortho-para-directive influence of CH3, we are going to mixture of these two compounds. Which is the major product? Out of these two major product, the compound which is more symmetrical will be the major. The Cl, this is more symmetrical as compared to this ortho isomer. That's why this product is the major product. This is the halogenation. Hydrocarbon, that is arene and derivatives, can be converted into haloalkanes by this substitution reaction, and this substitution is called electrophilic substitution. Cl positive joined to the carbon where more electron density present. That's why Cl comes at orthocarbon and paracarbon, because they are going to join in the form of positive ion, Cl positive. Okay. This is the one preparation. Second preparation is very important. It is too important as compared to the previous preparation. From second method is from aniline. Aniline. Aniline is an amine, and it is a aromatic amine. So aniline is this compound. Here is NH2, NH2. Aniline combines with nitrous acid. Okay. This NaNO2 combines with HCl, concentrate HCl to form HONO plus HCl. This HONO is called nitrous acid. Nitrous acid. Okay. Here we need nitrous acid for the reaction. And this is the source of nitrous acid. Nitrous acid is not stable, just like nitric acid. So it cannot be stored. It is prepared during the reaction, and this is the source of nitrous acid. That's why the reaction can be written in this way. Now aniline, here is NH2, combines with HONO plus HCl. It is looking somewhat odd, na? Why not HNO2? We are writing HONO. Sometimes in organic reactions, we are writing in this way. And this is better as compared to the HNO2. HNO, we have to remember. It is nitrous acid. Temperature is 273 to 278 Kelvin. This is called ice cold condition. 0 to 5 degree, low temperature, ice cold condition. Then you can remember this temperature. And it is going to form a compound. Here it is N2 positive Cl minus plus H2O plus H2O. This compound is called diazonium salt. Diazonium salt. Okay? Diazonium salt. The process is called diazotization. This is called diazotization. Sometimes they are asking the note, what is diazotization? Statement, aniline, this is aniline. Aniline combines with nitrous acid and HCl at low temperature to form benzene diazonium chloride, known as diazonium salt, and it may be abbreviated as benzene diazonium chloride, BDC. This method is called diazotization. Okay? Starting from this diazonium salt, we can prepare chlorobenzene, bromobenzene, iodobenzene, and fluorobenzene. All 4 types of haloarenes can be prepared from this compound diazonium salt. That's why this is important for examination point of view. Okay, let me write that. Conversion, in the form of conversion, it is also asked many times. Here it is, diazonium salt. I am starting directly from diazonium salt and to positive Cl minus. The question may be, how can you convert aniline into chlorobenzene? So first aniline we have to convert into diazonium salt, then diazonium salt into chlorobenzene. Here it is, see that. We are going to write 4 types of reaction: chlorobenzene, bromobenzene, iodobenzene, and fluorobenzene. So there should be sufficient space. When it is combining with Cu2Cl2 and HCl, cuprous chloride, it is going to form chlorobenzene, Cl plus N2. What are the other products? We need not to worry. This is the chlorobenzene. When this is going to combine with Cu2Br2 in presence of HBr, we are going to get bromobenzene. Here is Br and N2. And these 2 reactions are known as Sandmeyer's reaction, a name reaction that is important reaction, Sandmeyer. Sandmeyer's reaction. This is the next important name reaction. They are asking, write notes on Sandmeyer reaction. Then while writing this Sandmeyer reaction statement, when BDC, benzene diazonium chloride, combines with Cu2Cl2 and HCl, it forms chlorobenzene. This may also be written as a statement, diazonium salt combined with cuprous bromide and HBr, it forms bromobenzene. Okay? When it combines with Cu and HCl, copper and HCl, this forms chlorobenzene again plus N2. And here we can take copper and HBr. We get bromobenzene. Here the Br plus N2. These 2 reactions given by another scientist. And that scientist is, that reaction is Sandmeyer's reaction, Gattermann reaction. Gattermann reaction. This is the Gattermann reaction. It is not that important, that much important as Sandmeyer's reaction. It is very important, Sandmeyer's reaction. And another one, complete this table in that way. It is better to write in that way only. In the continuation, you can write, when it is combining with Ki, potassium iodide, and warm.
Sir, keep the camera downward.
Continuation. In continuation, you have to write here. The next condition is Ki and warm. Warm and heating is different meaning. Warm means heated up to the certain temperature, that is maximum 50 degree. That is the warm. We are going to get iodobenzene. Here it is I plus N2. This is not a name reaction. Okay. And final reaction to get fluorobenzene. The final reaction, the last reaction, chlorobenzene, it is allowed to combine with HBF4, hydrofluoroboric acid, HBF4. It is going to form an intermediate. This intermediate is unstable, N2 positive and BF4 negative. This is unstable. In organic reaction, sometimes we are using the bracket. This bracket means this compound is unstable. When it is heated, on heating further, on heating, that is called baking, means heating for a longer time at a certain temperature, limited temperature, we are going to get fluorobenzene. Here is fluorine and here is BF3, BF3 and N2. This is the reaction, this is the method. And this is a name reaction called Balch-Schiemann. Balch-Schiemann reaction. Okay. So in this method, we have studied three important reactions: Sandmeyer's reaction, and there is Getterman reaction and Balch-Schiemann reaction. First and this last reaction is very important. They're asking about note, to write note on these reactions. Okay, students? So if any doubt, you can ask me at any time. This organic chemistry, I'm trying to clarify the doubts along with the reaction. If any difficulty you feel anywhere, you can ask at any time. Thank you, bachcho. Thank you very much.
Thank you, sir.
Thank you, beta. Thank you. घर जाके साइन